Okay. The first graphing inequalities video had a mistake in it, so we're going to correct that this time, and that's thanks to Ian. A very important concept before we start talking about graphing inequalities is whenever we multiply or divide by a negative number, we have to flip the inequality sign. So we'll get into that here, and I'll show you what I'm talking about. Okay, so first we have this inequality, 3x minus 2y is greater than or equal to negative 4. The first thing we want to do is solve for y. So I need to subtract 3x from both sides. And that'll leave me with negative 2y greater than or equal to negative 4 minus 3x. Now I need to isolate the y, in other words, get the y by itself, so I have to divide both sides by negative 2. And that's when the alarm bells need to go off and we flip that sign. So negative 2 divided by negative 2 is just a 1 coefficient. Negative 4 divided by negative 2 is 2. And a negative 3 divided by a negative 2 is a positive 3 halves. And that's our slope. We have slope with a 2 intercept. So now I can graph this line like an inequality with an y-intercept of 2. And then the slope is 3 over 2. 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 All right. The next thing we need to decide, is it a solid or a dotted line? And because it could be equal to, you see the half of an equation sign, that means we can draw a solid line. Because the solution set could be on the line. But because it's an inequality, we have to know where to shade for the other solutions. Now, if you're not sure where to shade, we can use a test value. Since the origin, 0, 0, remember the origin is where the x and y axes meet, and that's 0, 0. And that's the easiest test value. So we're going to test this side of the line. So we put in a 0 for y. We put in a 0 for x. And we end up with 0 is less than or equal to 2. And that is true. So since that's true, we can shade the side where 0, 0 is located. So not only are the solutions on the line, they're below the line. And we can shade the whole area. So all the solutions to this inequality, negative y is less than or equal to 2 plus 3 halves x, lie on the line or below the line. Okay, awesome. Let's go to the next part of this worksheet. Now we have the same numbers here. And remember, we had to switch the sign each time. So here we have y. And because we're going to be dividing by a negative 2, we're going to switch this inequality sign. And we still have the same numbers, 2 plus 3 halves x. And down here we still have the same numbers, but we're going to switch that inequality sign because we divided by negative 2 on both sides. So we switch that inequality sign, and we still have the same numbers, 2 plus 3 halves. Okay, so here it can be greater than or equal to. So we know since we have an equal to, we can use a solid line. We still have the same y-intercept. We still have the same positive slope, 3 over 2, 3 over 2, and so on. And because it could be equal to, we can grab up a line. Let's do that real fast. There we have it. Now down here, it's just less than. So we'll go ahead and quickly do the intercept. And 3 over 2, still the same slope. But because it can't be equal to, only less than, we have to do a dotted line. So let's get that dotted line. That means the solution cannot be on the line. The line is more or less operates like a fence or a barrier, and of which the solutions cannot cross. Okay, so we want to use that test value again of 0, 0, and we can use that origin because it does not lie on the line. You know, if your line did go through the origin, you'd have to use a different test value, something above or below the line. But we can use 0, 0 again. So 0 greater than or equal to 2. And of course, if we put a 0 in for x, we just end up with 0 times 3/2 or 0. And we end up with the inequality 0 is greater than or equal to 2. But is that true? No, that is not true. So all the values down here are not in the solution set. However, that means the other side of the line contains the solution set. So we can shade in all of that side of the line. And remember, these graphs go on forever. This is just the limitations of a two-dimensional representation of a graph. Okay, on the other graph, we already know that the solution set cannot be on the line, but we need to know which side to shade. We could still use the same test points, 0 for y, less than 2, and of course we end up with a 0 here because x is 0, 0 times 3/2 is 0. Now, is 0 less than 2? It is. So, everything on this side where 0, 0 is a solution. So I can shade in this part of the graph. All right, so hopefully I fixed that misconception because earlier I forgot to switch my inequalities. And remember, we must always switch our inequality signs whenever we multiply or divide by a negative. I hope this helps with your classwork. Thanks.